Hello students, welcome back to the channel. So today's topic that we have already discussed is on the finding diagonal matrix for a 3x3 matrix. Okay, the first step will be always the same, that is A minus lambda I is equal to 0. So I will write it directly. Only the diagonal elements with the lambda will be added. Okay, it is minus 2 minus lambda, 2 minus 3, 2, 1 minus lambda, minus 6, minus 1, 2, 0 minus lambda is equal to 0. Now what I have to do is, okay, let me write it as minus lambda only. Okay, now after this the main thing that we have to do is finding the characteristic equation. Now in order to go and open and do our traditional method, I will go with a shortcut. Okay, that is, a formula is lambda cube minus a lambda square plus b lambda minus determinant of a is equal to 0, where a is the sum of the diagonal elements, right? It is nothing but a is nothing but the sum of the diagonal elements of a. So that will be minus 2 plus 1 plus 0 is equal to minus 1. So what is the value of a? A is equal to minus 1. All right, now let us find b. Okay, let us find b. So what is b here? B is equal to, it is the sum of the minus of the diagonal elements. Okay, diagonal elements of a. Now in order to do that, so let me write the three elements, or first let me write the matrix first, so that it will be easy for me to write it down in the equation. So b is equal to what? So we have three terms which should be added. So what should be that? 3 minus should be given. So first row, first column, the first diagonal element is minus 2. So delete that numbers, delete the elements of the first row and the first column and write the rest of the elements. Now let me take the second diagonal element, that is 1. So rest of the numbers we will write, that is 2 minus 3 minus 1, 0. Then we will write the last term, that is the 0, the last diagonal element, 0. So that will be what? That will be here it will be minus 2, 2, minus 2, 2, 2, 1. So make a correction here that I have written 2 there, make it minus 2. All right, now let me solve it. It's 1 into 0 minus 12. The next element will be, or let me write directly, so it will be minus 12 and minus 3 minus 6. Okay, so what I will get? So the b term will be minus 21. All right, now we have all the terms and I have one term remaining, that is the modulus, the determinant of a. So finding the determinant of a is minus 2. Let me write the matrix again. It is minus 2, 2, minus 3, 2, 1, minus 6, minus 1, minus 2, 0. Now I will find the determinant along the first row. Okay, first row. Okay, so what will be, how to find the determinant is the first element, minus 2 into 0 minus 12 minus 2 into, right, it is plus minus plus, so minus 2 into 2 into 0 is 0, right, 0, and minus 1 into minus 6 will be so it is 0 minus 6, right. So minus 3 into minus 4 plus 1. Now solve the solution. So it will be 24 plus 12 plus 9. So what you get? It is determinant of a is equal to 45. Now substitute the values over the equation, that is lambda cube plus lambda square minus 21 lambda minus 45 is equal to 0. All right, now this equation you have to solve using your scientific calculator. Okay, pause the video, solve for the roots and get the roots for the eigenvalues. So the eigenvalue will be, so use the scientific calculator, so I am specifying it. The eigenvalues will be lambda is equal to 5 minus 3 minus 3. All right, so the first step is done, finding the eigenvalues. Now the second step, that is finding the eigenvectors. Okay, we have the eigenvalue. Let us find the eigenvector, that is x, right? X is equal to x1, x2, x3. All right, x1, x2, x3. Okay, Now, for say a minus lambda, what is the formula for finding the eigenvector? It is a minus lambda I into x is equal to 0. So let me write the equation. It is 2 minus lambda minus 2 minus 3 2 1 minus lambda minus 6 minus 1 minus 2 minus lambda. Okay, x1 x2 x3 is equal to 0 0 0. So now we have this equation. Let us go on substituting the values of eigenvalues to the eigenvector and get the eigenvectors one by one. So for lambda is equal to 5, since I have the values, I will write it directly. So it is minus 7, 2, minus 3, 2, minus 4, minus 6, minus 1, minus 2, and so minus 1, minus 2, and minus 5. Okay, now what will be the values? x1, x2, x3, and the last one will be 0 0 0. All right, now we know to write the equation. So minus 7x1 plus 2x2 minus 3x3 is equal to 0. 2x1 minus 4x2 minus 6x3 is equal to 0. Minus 1 or minus x1 minus x2 minus 5x3 is equal to 0. Since all these equations are not dependent to each other and the equations are different from each other, you can take any two equations and you can solve the equations and get the values of x1, x2, x3. Okay, I will take the equation say 2 and 3. You can take the equation say 3 and 4. You can say 2 and 4 and so on and so forth. So once you have got all these values, now let me take the two equations, that is 2 and 3, and let's solve it. So how to write that? x1 is equal to minus x2. Okay, first I will just construct how does it look, then we will go on filling the values. So for x1, you have to, apart from x1 values, you have to write the values of x2 and x3. For x2, you have to leave the values of x2, you have to write x1 and x3. For x3, you have to leave the values of x3 and you have to write the values of x1 and x2. So once that is done, solve the values. So what you get? You will get minus 12 is equal to minus x2 divided by, so it is 42 plus 6 and x3 divided by 28 minus 4. Solve it. It is x1 divided by 24 is equal to x minus x2 divided by, or minus 4 is equal to x3 divided by 24. Okay, you can divide it, you can take the common term out. So minus 1, this will be minus 2 and this will be 1. So what are the values of eigenvectors for lambda is equal to 5? So eigenvector x1 is equal to, it is minus 1, minus 2 and 1. Okay, now the thing here is you have to find the eigenvector for lambda is equal to minus 3. So similarly you have to fill in the value for lambda and you have to get the matrix. So it is 1 2 minus 3, 2 4 minus 6, minus 1 minus 2 3, and you have x1 x2 x3 is equal to 0 0 0. Okay, now write the equation as usual. It is x1 plus plus 2x2 minus 3x3 is equal to 0. 2x1 plus 4x2 minus 6x3 is equal to 0. Minus x1 minus 2x2 plus 3x3 is equal to 0. Now if you see the three equations, all the three equations are same. Consider the first one. Okay, consider the second one. If you remove the 2 outside, so you will get the it is same as the first one. If you take the minus sign outside for the third equation, you will see it is similar to the first one. So take any one of the equation that you have to solve. Take any one. So I will take the first equation, that is the fifth. Let me give the number as 5. So take fifth one to solve the values. Okay, so what you have to do here, when all the values, three equations are same, you have to choose any two values of say x1 x2 or x2 x3, and you have to guess, you have to select the values, okay, of any two say x2 x3 of your choice. So I will take the values, so I will write it down, choose any two numbers and substitute. So I will take the values of x2 and x3 and I will find x1. Okay, so let x2 be 0 and x3 be equal to 1. Okay, now what I will get, x1 as, substitute this value to the first equation. So what you will get the equation as, so let me write it down, x1 plus 0 minus 3, right? Yeah, it should be 3. Yeah, minus 3 is equal to 0. Yeah, so x1 will be what, is equal to 3. So what happens now, you have to write the, so since we have already chosen the values, we are already we are taking the values as similar. Okay, so this will be your second eigenvector. So whatever you have chosen, so x1 will be 3, x2 will be 0 and x3 will be 1. So now case 3 is what, the eigenvalue for lambda is equal to minus 3 again. So I need not write the equation, but I will reuse the equation 5th, okay, here. So now what you have to do is, so let me write the equation first. It is x1 plus 2 x2 minus 3 x3 is equal to 0. So once this is done, what I will do is just interchange the value of x1 and x2 and x3 that I have previously taken. Previously it was 0 and 1. Now I am taking as 1 and 0. Substitute the value. So x1 you will get it as, so x1 will be equal to plus 2 minus 3 is equal to 0. So it is x1 is equal to minus 2. So you got the third vector, that is x1, x2, x3 is equal to minus 2, 1 and 0. Minus 2, 1 and 0. Since you have 3 vectors ready, now what you have to do is you have to solve for the modal matrix. Okay, what is modal matrix? It is nothing but it is a combination of all the 3 vectors written in this way. Okay, so p is equal to minus 1, 2, 1, 3, 0, 1 and minus 2, 1, 0. Once you got the modal matrix, what is the formula? Formula is equal to d is equal to p inverse of AP. Okay, A we have, P we have. So the first thing we have to find is P inverse. Okay, we have already seen how to see P inverse for 2 cross 2 matrix. Let's see how to solve P inverse for 3 cross 3 matrix. What is the formula? It is adjoint of P divided by the determinant of P. So let's solve for adjoint P now. Okay, there are 3 steps that you have to follow in order to find the adjoint P. So it's nothing but it is a cofactor of the matrix and the transpose of it. Okay, let's see, let's break down. Okay, the first step that you have to solve while solving for the adjoint is, the first step is you have to find the minor. Okay, second one is you have to find the cofactor, and then you have to do what, the last step is finding the transpose. The first step is very important. Okay, finding the minor. Once that is done, finding cofactor and transpose is very easy. So what is minor? Minor is nothing but, minor I will write it down as, say the formula will be so minor m11, so it goes on m11, m2, m12, m13. So you have to delete the r1 and the c1, and you have to delete the first row and the first column, and then you have to write the factors of it. Okay, so what are the remaining elements? Okay, let me write the P matrix here so that it will be easy for me, right? Minus 2, 0, 1, 1, 1, 0. Okay, so what are the values that I have to write? It is 0, 1, 1, 0. So deleting the first row and the first column, solve for it. It is 0 into 0, 1. It's minus 1 into minus 1. It is 0 minus 1 is minus 1. So then I will go with m12. That is m12. You have to delete the row 1 and column 2. Okay, so what that will be? Minus 2, 1, 1, 0. Right. So what will I get? So it will be minus 2 into 0, minus 1, 1. Okay, so yeah. Now m13, I have to delete the row 1 and column 3. Okay, so what will I get? It is minus 2, 0, 0, 1. Right. After this we get the multiplication. We'll do the multiplication. Minus 2 into 1, minus 0 into 1. So you will get minus 2 as a value. Now m21, so what you have to do, you have to delete the value of row 2 and column 1. I will write it directly. So it is 3 minus 2, 1, 0. 3 into 0 minus 2 into 1, so it will be 2. Next m22. Okay, m22 is what? It is minus 1, minus 2, 1 and a 0. So the value will be minus 1 into 0, minus of minus 2 into 1. So minus 0 minus of minus 2 will be 2. M31 is what? 3 minus 2, 0 plus 1. So the value will be 3 into 1 minus minus 2 into 0. You will get as 3 minus 0 as 3. Now M32, delete row 3 and column 2. So minus 1 minus 2 minus 2 1, that will be minus 1 1 minus minus 2 into minus 2. So the answer will be minus 5. So last one, M33. So you have to delete the row 3 and column 3. So minus 1 3 minus 2 0, that will be nothing but minus 1 into 0 minus 3 into minus 2. So the value will be nothing but 0 minus of minus 6. So you'll get 6. Now the minor of the element will be written in the matrix M as like this. Okay, whatever the new values you have gotten, you have to write it in the matrix. So that is a minor. Okay, so that is 2 to minus 4 minus 3 minus 5 and 6. Now first step is done. Now finding the cofactor. Okay, cofactor, what you have to do is, so remember this matrix, plus minus plus minus plus minus plus minus plus. Now you have to multiply this minor with this cofactor matrix. Okay, you have that, what that means, the whatever the signs will be there, it will be changed, right? Plus into minus will be minus, minus into minus will be plus, right? Plus into minus will be again minus, minus into plus will be minus. So go on multiplying, right? So it will be 4, it will be 3 into plus will be 3, minus into minus will be plus 5, 6 into plus 6 will be 6. Now this is the cofactor. Now what we have to do, we have to find what is the adjoint P. It is a cofactor, is nothing but transpose of the cofactor. So do the transpose. It is nothing but row becomes column, column becomes row, right? So just rewrite the matrix in the transpose form. So this is the matrix that you have got. Now we already got the adjoint P, right? What is the formula for P inverse? P inverse is nothing but adjoint P divided by determinant of P. So what is remaining? We have to find the determinant of P now. So I will find the determinant of P along with the first row. Okay, so the first row element into the elements will be minus 1 into minus 1, minus 3 into minus 1, minus 2 into minus 2. So the value will be 1 plus 3 plus 4 is equal to 8. So the determinant of P is nothing but is equal to 8. Now we have to substitute, right? Once we have all the terms of the diagonal formula, that is P inverse AP, you have to substitute. So we have 1 by 8 into, I am writing the what is P inverse. Okay, so it is minus 1 minus 2 3 1 2 5 and minus 2 4 and 6. Substitute this. Okay, substitute this in the equation. So I will write it down. It is nothing but 1 by 8 into minus 1 minus 2 3 1 2 5 5 and minus 2 4 and a 6. What is A matrix? A matrix is nothing but the original matrix, minus 2 2 minus 3 2 1 minus 6 minus 1 minus 2 and a 0. The P matrix will be minus 1 3 minus 2 minus 2 0 1 1 1 0. Okay, the first thing we will do is multiplying these two matrices. So minus 1 minus 2 3 1 2 5 minus 2 4 and a 6. So once that is in first row, first column, right? Minus 2, so I will write it directly. It is 2 minus 4 minus 3 6 minus 6 plus 0 minus 3 4 plus 2 minus 3 into 0 will be I think it is 0, right? Yeah. Now for the next term will be 2 into minus 1, right? It is nothing but minus 2 minus 2 minus 2 minus 6 6 plus 0 minus 6 and minus 4 plus 1 plus 0. Last one is plus 1 plus 4 plus 0 3 plus 0 plus 0 2 minus 2 plus 0. So now solve So it is 1 by 8 is equal to, sorry, 1 by 8 into minus 1, minus 2, 3, 1, 2, 5, minus 2, 4 and a 6. So after solving this, minus 5, minus 9, 6, minus 10, 0 and a 3, minus 3, 5, 3 and a 0. Now multiplying the last two matrices. So it is 5 plus 20 plus 15, 9 plus 0 minus 9, 6 minus 6 plus 6 plus 0, minus 5, minus 20, minus 20 plus 25, minus 9 plus 0, minus 15, then 6 minus 6 plus 0, 10 minus 40 plus 30, then 18 plus 0 plus 18, then last one minus 12 plus that will be how much, it's 12 minus 12 plus 0. So the answer will be 1 by 8, 40, 0, 0, and here will be 0, minus 24, 0, 0, 0, minus 24. Now multiply 8, so that will be division. 40 divided by 8 is 5, 0, 0, 0, minus 3, 0, 0, 0, minus 3. So now I can clearly say that the diagonal elements are all the numbers and the rest of the elements are 0. So it is a diagonal matrix D, which follows the definition of the diagonal matrix, and also how to check whether the answer is correct. The eigenvalues are written in the diagonal form, so I can also say that the answer you have got is also correct, right? So that is all, guys. Meet you in the next video. Thank you.